Finite element analysis of bullet impact on Kevlar fiber reinforced composite using Autodyn. Abstract: the penetration and perforation behavior of Kevlar fiber reinforced composite, KFRCP, plate under impact is investigated numerically in this paper. The described numerical analysis was carried out with the Autodyn hydrocode, which included the shock effect due to impact in the modeling. The focus of this research was on the progressive damage behavior and modalities of damage evolution in laminated materials. The three-dimensional, 3D, progressive damage patterns and perforation behavior of 3D printed plates under impact are highlighted in a number of novel results. For the design and analysis of KFRCP, a few critical parameters such as material, thickness, and impact condition will be explored to improve the crashworthiness design in low-velocity impacts. Determining the maximal deformation, von Mises stress, and energy absorption behavior by modeling. Keywords: Kevlar fiber reinforced composite, three-dimensional. Introduction. During the last decade, substantial research has focused on experimental and computational simulations of KFRCP under ballistic impact to better understand the target material's post-impact behavior. Nomex and Kevlar aramid fibers were used to make several types of body armor, Jessel and Gosch, 2002. Experiments, analytical formulations, and numerical simulations were used to carry out these investigations. VCL's ballistic response was measured in terms of ballistic limit, damage patterns, and energy absorbed by the target when they collided with various projectiles. Hydrocode simulations have been used to validate the damage patterns observed from experimentation. Autodyn 3D was used, and a good comparison was found. Several researchers looked at the ballistic impact. By performing on a Kevlar composite target. Hydrocode simulations are used to do parametric investigations. These researches advocate for the use of hydrocode simulations to create a ballistic model. Anderson, 1987. Fiber-reinforced polymer matrix composites are currently one of the most advanced commercially available materials. They're commonly used in aerospace and defense-related industries. As well as their use in building, automobile, and other fields. Sports goods manufacturing is also very common. The most important the rationale for the composite's broad adoption, as previously stated, Gruhisic et al., 2009. Finite element analysis, FEA, is a method of analyzing a material or design using a computer model. It's utilized to improve existing or new products. A corporation can verify that a suggested design meets the client's specifications if certain conditions are met. Manufacturing or construction are two options. It is possible to improve an existing product or building by modifying it. If the model fails, FEA can assist the designer in modifying the design to obtain the desired outcome. By displaying trouble areas on a model, FEA assists analysts in predicting failure due to unknown stresses. Designers will be able to visualize all of the theoretical tensions within an object. Rather than creating and assembling, this strategy can assist cut production costs and time. One of the aspects of finite element analysis is explicit dynamics. The ANSI explicit dynamics product set assists users in achieving their goals. Insight into the physics of short duration events for items that are subjected to extreme temperatures. Dynamic events that are nonlinear and transitory. The explicit dynamics products from ANSI, Graia and Vinci, 2021. Methodology. The endeavor begins with preliminary study on the issue in the form of articles and research papers. After gaining a sufficient level of comprehension of the subject, software will be employed to complete the remaining tasks. Explicit dynamics will be used to build a rudimentary model with basic bit and formation design. Explicit dynamics will be used to build a rudimentary model with basic bit and formation design. This is where all of the essential parameters will be specified. After that, the model will be imported into Autodyn, Fedorova et al., 2016, a different solver. After that, Autodyn simulations will be run with this model. The success of the Autodyn simulation will be critical to the project's success. Explicit dynamics will be used to build a rudimentary model with basic bit and formation design. This is where all of the essential parameters will be specified. After that, the model will be imported into Autodyn, a different solver. After that, Autodyn simulations will be run with this model. The success of the Autodyn simulation will be critical to the project's success. Matema et al., 2020. Preliminary model. A preliminary model is built to familiarize yourself with the software, and then it is run for simulation. This prototype model consists of only two cylinders, one that represents a bit, and another that depicts the formation itself. The model setup is broken down into a few steps, which are outlined in Fig1. Drop tests, collisions between colliding objects, and penetration are all examples of scenarios where explicit dynamics is employed to research or mimic. The materials are chosen and imported here in order to eventually fill up the gaps. Conclusion. In this paper, a numerical simulation of the ballistic impact of a steel projectile on an armor steel plate using a 3D nonlinear explicit finite element formulation available in ANSYS/Autodyn is conducted using a rate-dependent, simplistic material model of plasticity coupled with a failure criteria. The ability to comprehend the material model, failure criteria, and ballast mechanism in penetration simulations, the impact is amplified. Impact studies on glass/epoxy laminates revealed that the results varied due on slanted impact rather than regular impact. When a bullet impacts the laminate in a regular direction, it absorbs less energy. The type of impact determines whether a plug or a pedal forms. Experiments revealed that crack propagation under the catastrophic situation.